Hey guys, I'm Crystal, and I'm here to talk to you a little bit about game theory. Now, game theory is math that you can actually use in real life, which is kind of cool. There's a lot that goes into game theory, though. So, let's just talk about some of the basics. For all games and scenarios that involve game theory, you have your players, your possible outcomes, and your solutions. For any game or decision that is being made, there will always be a player. So essentially, these players are people doing the actions or making the decisions. Your possible outcomes are always going to be the options that you have. And the solutions are your optimal plan of action, or the Nash equilibrium. And the Nash equilibrium is just the best payout for both players. Pretty self-explanatory. There are essentially two types of games. You have your simultaneous and your sequential. A simultaneous game is where two or more players make a decision at the same time. For example, rock, paper, scissors. Each player needs to make the decision at the exact same time to make it fair. However, rock, paper, scissors doesn't have an optimal solution, and that means that there's no one choice better than the other. I'll prove it to you. So first, let's make a chart. -1 means it's a loss. 0 means it's neutral and nobody wins. 1 means that it's a win. So it'll end up looking like this. And you always want to look at the chart as if you were going to graph it. First, we need to figure out what player 1 should throw depending on what player 2 throws. The easiest way to do that is to break the chart up into sections like this. The red star is going to indicate player 1's best option, which in this case is scissors. Then we look at the next row and do the same thing. In this case, the best option would be paper against rock. Then finally, we look at the third row and see that player 1's best action is to throw scissors against paper. And your chart should end up looking something like this. Now, let's do the same, but with player 2's options. We need to do the same thing, but instead of looking at it in rows, we're going to look at it in columns, like this. Remember, we are looking at this as though we wanted to graph it, so player 2's outcomes are going to be on the right side. And let's label this with a purple star. So here, player 2's best option is going to be rock. And the next column would be paper. And then scissors. So then player 2's payoffs should look like this. And once we put all that together, we should get something that looks like this. As you can see, there's no pair that has 2 stars on it, and that means there's no Nash equilibrium, or any equilibrium at all. So this means that there's no choice better than another. An example with a Nash equilibrium would be something like the prisoner's dilemma. In the prisoner's dilemma, 2 people are accused of a crime and have been brought in for questioning. Let's say if they both confess, they each have 5 years in jail. But let's say one talks and one stays quiet. The one that talks will only have 3 years in jail, while the one that stays quiet will have 10 years in jail. But if they both stay quiet, they each have 7 years in jail. So let's figure this out like we did with the rock, paper, scissors example. So first, let's set up a chart like this. And let's find player 1 and 2's dominant strategies. Player 1's strategies. Player 2's strategies. Now let's look at the complete chart. Now looking at the complete chart, you can see that if both players stay quiet, then there's an equilibrium because it has 2 stars. But in this case, it's not the actual solution. There are actually 2 equilibriums in this problem, but both of them talking is actually a Nash equilibrium because if we look at this logically, neither player wants to 1, risk having a 10-year sentence, and 2, talking with them both a shorter sentence than what they would with staying quiet even though they'd be writing the other out. Sequential games are games where one player makes a move and then another player makes a move. It's kind of like a board game. The best way to solve this kind of problem is to use backwards induction to find the Nash equilibrium. And what does that mean? Well, backwards induction is just a fancy word for saying solving a problem backwards. And as I said before, the Nash equilibrium is the best payout for both players. Say you have a firm that wants to enter a market, but another firm already exists. The entering firm has 2 options. It can enter or not enter. If the firm does enter, then the existing firm has the option to compete or not compete. Now let's solve this using backwards induction. If the firm were not to enter, the firm wouldn't earn anything, but the existing firm would gain everything, represented by 0 and 100. If the firm enters and the existing firm decides to compete, then it would hurt both of the firms, represented by -10 and -10. If the firm enters and the existing firm decides not to compete, then they both gain. This is represented by 50 and 50. Now we need to look at this logically. If the firm doesn't enter, it gets nothing, so that's very unlikely to happen. So let's cross that off. Next, we look at if the firm enters and the existing firm competes. Well, if this happens, they both lose, so neither of them really want that to happen. So we can cross that off as well. Then we look at what we're left with. The firm entering and the existing firm not competing. And this will be our Nash equilibrium, because both players will be benefiting. But game theory is more than just games. It has to do with optimization, auctions, elections, and even stocks. Optimization is trying to get an ideal value. Say you have a pen where you keep your livestock and you have a fence to separate the different types of livestock. You need to figure out the dimensions of the pen to create the greatest amount of area. Say you know you have enough wood to cover about a 200-yard perimeter. First, you need to come up with your equations for your perimeter and your area by labeling each section. Let's label the horizontal borders x and the vertical borders y, which end up to be p equals 4x plus 3y and a equals y times 2x. And since we know our maximum perimeter is 200, let's make p equal to 200. Now we need to solve for our variables. Let's take our perimeter equation and solve for x. First, subtract 3y, and then divide by 4. Then plug in your new x value into the area equation. Distribute the 2 and then multiply by y. And then you can simplify it even further like this. Then what you need to do is take the derivative and solve for y. It should look something like this. Once you find y, plug it back into your perimeter equation and solve for x. Now that you have both your variables, you can plug it back into the area equation. So now we know what each variable of the pen has to be in order to create the greatest area of 1,666.5 yards. Each x will represent 25, and each y will represent 33.33. Now, let's talk about auctions. There are many types of auctions, but they all have something in common. Something to give away. Ever wonder how Quibids.com can auction things and only have the increments go up by a cent? Well, it's a bidding fee auction, or a penny auction, which is a type of all-pay auction, which means you pay for each bid you place, even if you don't win the auction. A Japanese auction is like a regular auction, but if you don't bid around, you can't re-enter the auction. A Chinese auction is where everyone makes a bid, but the winner is chosen randomly, so like a raffle. A fixed price auction allows an auctioneer to auction off an item at a predetermined price. This is kind of like the eBay's Buy It Now option. A blind auction doesn't mean you can't see what you're bidding on. It just means that you can't see what the other bidders are bidding. A bidder's choice auction is placing a bid on a group of objects, but the highest bidder only gets to pick one item from that group of objects. So this auction is based in rounds. Unlike many different types of auctions, elections really only have two types: populist and Condorcet elections. The populist election is something we use here in the US, which means whoever has the most votes wins. A Condorcet election is when voters rank their candidates and the candidates win by a majority rule. If we have towns voting on a new governor, and say there are 3 governors trying to get elected, each town or city will rank those governors. Then we add up all the votes and see who has the most in the end. Even the stock market has game theory, especially when determining when to buy and sell stocks. By looking at the stock trends, you can make an estimate as to when you should buy and sell your stocks. Stocks are affected every day, so it's important to look at the news and do some research on the stock before you invest. Say you're invested in an oil company, and they have been steadily inclining their profits, so you hold on to those shares. But then the oil company you invested in has an oil spill. your profit just plummeted and you're suddenly losing a lot of money. You have three options. You can sell what you have, try to trade your shares, or you can wait and see if the stock will bounce back. But this can take a really long time for that to happen. And you don't know if the stock will be greater than what it was, be less than what it was, or if it's going to even out at some point. So in my opinion, it's better off not to invest in something so risky. Game theory also has a huge role in war strategies. Without it, we probably would have been blown up in the Cuban Missile Crisis. Now, we can't recreate the Cuban Missile Crisis, and nor do we want to. So another example would be the Joker's social experiment in The Dark Knight. Take a look.
Tonight you're all going to be a part of a social experiment. I'm to blow you all sky high.
Liberty come in, over. He's dead.
Anyone attempts to get off their boat, you all die. Each of you has a remote. Blow up the other boat. At midnight, I blow you all up. If, however, one of you presses the button, I'll let that boat live. So, who's it gonna be? Harvey Dent's most wanted scumbag collection, or the sweet and innocent civilians? You choose. Oh, and you might want to decide quickly, because the people on the other boat may not be quite so noble.
Stay back.
Well, now, who are you to decide? We ought to talk this over, at least.
We don't all have to die. Those men had their chance.
We are not going to talk about this.
Why aren't we talking about it?
We're talking over the same exact thing on the other boat.
Let's put it to a vote.
140 against, 396 for.
Go ahead. Do it.
We're still here. And that means they haven't killed us yet either.
Give it to me. You can tell them I took it by force. Give it to me, and I'll do what you should have did 10 minutes ago.
And here we go.
When the Joker puts the lives of civilians in criminals' hands, and vice versa, the civilians nor the criminals can push the button because they don't know if they can trust the Joker, the game organizer, because what if he had given them their own detonator? They'd be blowing themselves up, but as time kept passing and neither had blown up the other, they both realized that neither of them were going to do it. Another great example would be in the Avengers when Tony is talking to Loki and trying to convince him that he'll lose. Here's the clip.
That's what we call ourselves.
Earth's mightiest heroes type thing.
I have an army. We have a Hulk.
That not enough proof for you? Have another look.
Enough! You are all of you beneath me. I am a god, you dull creature, and I will not be bullied by that.
Puny god.
And I'm pretty sure this one explains itself. And now that you know a little bit about game theory, try applying it to your everyday life and see if it makes a difference.